In the today's class, we'll discuss the numericals on the filter design. Alright. So already the theory part is discussed and we have solved some numericals in the lab session. Today's class also we'll solve one or two numericals. Just take this one. Design a Butterworth filter, Butterworth low pass filter has to meet the following specifications. The given data, right? So the given data, passband gain is given. Passband gain Kp is equal to minus 1 dB at the cutoff frequency omega p 4 radian per second. Second one, stop band attenuation greater or equal to 20 dB at omega s is equal to 8 radian per second. Determine the transfer function. Determine the transfer function with the lowest order. All right. So we have to design the filter for the lowest order. So filter is basically, we know, right? So designed for remove the unwanted signal or noise signal, right? So again, it is classified into two types of the filters: analog filters and digital filters, right? So see here, all the thing is all the basics we have discussed in the regular lab sessions. So here they are asked to design the transfer function for the given filter. So for that, given passband gain is given and stop band attenuation is also given. So for that, every filter, right? So the first step is draw the diagram, right? So whatever the given data, so on that, so they have mentioned low pass filter. Here it is, they have mentioned low pass filter, right? So we know some basics, right? So the low pass is nothing but, so the filter which will allow only this frequency. This is the low pass filter, right? So high pass filter, the high pass filter is nothing but it will allow the higher frequency. This is the high pass, right? So the next one is a band stop and band pass. So right, so this is the band pass filter. So it will allow this frequency only from this point to this point. So from this onwards, it will allow. This is the frequency which the filter will allow. The band pass filter. The last one is band stop filter. right? Band stop filter. So see here, if I mention, right, so if I mention I want from this much to this much frequency only allowed, so that time we are using low pass filters. I want more than 100 radian per second, that frequency we want, so for that we are using high pass filters. So in the some filter design, right, some of the application we want 40 to 60, in that band we want, so for in that case we are using band pass, and 0 to 20 and 80 above, so that time we are using the band stop filters, right? So in the given numerical they are asked for low pass filter design. So low pass filter is nothing but this one, this is the low pass filter. So pass band gain is given, the pass band gain is given, so that is nothing but, in the y-axis we are taking the gain, remember, and here we are taking with respect to the frequency, that is nothing but omega, right? Frequency, or else we can write it as a omega. It is nothing but radian per second, right? So here it is 0 dB, here it is -1, kp is equal to -1 dB. What is the value now? It is omega p is nothing but 4 radian per second. And stop band attenuation means we have to stop, more than that it is not allowed. So they have given that is nothing but 20 dB, right? So this is nothing but, I will write ks is equal to -20 dB, 20 dB. So that value is nothing but omega s is equal to 8 radian per second. Radian per second. First draw the, by the given data, just draw the filters. The first step is we have to find, the first step is we have to find the order of the filters. Alright, so we have to find the order of the filter. Alright, the first step is we have to find the order of the filter. Order of the filter, we have to find it. That is nothing but we have the equation. N is equal to, remember this one, log of 10 raised to minus kp by 10 minus 1 divided by, right, 10 to the power minus ks divided by 10 minus 1, right? So whatever the answer is there, so for that take the log divided by 2 log omega p by omega s. Remember, this is the formula to find the order of the filters, omega p by omega s. Substitute the values. N is equal to log of what is the kp value? Kp value is minus 1 dB. So this minus and this minus, so it will be plus. So 10 divided by 10 raised to kp value is nothing but minus 1. Remember, so minus 1 into minus 1 plus, so 1 divided by 10 minus 1, right? So divided by, what is the ks value? Ks value is nothing but minus 20 dB. So minus into minus plus 20 by 10. So 10 raised to 20 by 10 minus 1 divided by 2 log of omega p. What is the omega p value? 4 divided by what is the omega s value? 8. Use the calc. See here in the calc in the 991 ES, first set the mode, press shift 9, so after that 3, reset it, shift 9, 3 and equal sign, reset the whatever the settings, right? So after that go for the shift mode. No, in the mode option choose the complex 2, that is nothing but 2. Once you are done, again we have to solve these numericals in the radian only. So for that press only mode, not mode, shift mode, right? Shift mode. So here so many options are there. So radian is there, degree is there, right? Science mode is there, normal mode is there. So we want in radian mode, press 4. So now it is complex and radian mode is selected. See here once again, shift 9. So you have to reset all the parameters, press 3. After that shift mode 2, that is complex is selected. After that degree is there. If I want to set radian, press shift press, so after that press 4, radian is selected. See here, after that enter the values, log of 10 raised to 1 by 10, that is nothing but 10 raised to 0.1 minus 1 divided by 20 by 10, it is nothing but 10 raised to 2 minus 1 divided by 2 log of 4 by 2, 4 by 8, it is nothing but 1 by 2. Use the calc and find the answer. N is equal to 4.28. So we have to go it for the next order. So that is nothing but N is equal to 5. Use the calc. Just check the answer. 4.289. 4.289. So just choose it for the next order. That is nothing but 5. So remember this formula, it is very important. This formula, remember to find the order of the filters. In any numerical, if it is 10 marks is there, so order of the filter it will carry. So this will carry 1 mark and this will carry 3 marks. Remember this one. After that, so now the order of the filter is fixed, that is nothing but N is equal to 5. Now we have to find the poles, right? So poles of the system, so we have to find, that is nothing but we have the one more equation, Sk is nothing but number of poles is equal to 1 at an angle of theta k. Alright, so and k is varying from 0 to 2n minus 1, means for the given the problem n equal to 5, so 2 into 5, that is 10, 10 minus 1, 9. So means we have to, for the given numerical, we have to carry it for up to 9. Alright, so one more formula we have, theta k. right? Theta k, we have the formula. What is that? Theta k is nothing but, remember, pi k divided by 2n plus, pi k divided by n, n, pi k divided by n. So pi divided by 2n plus pi by 2. This is the second formula, remember. And here k is varying from 0 to 9. 0 to 9. So see here, we have to find the values. That is nothing but, so k is varying from 0 to 9. It means S0, S1, S2, S3, S4. Right? So like that we have to find. Right? So up to S9 we have to find. Alright, so see here, I will write, so S0, S1, S2, S3, S4, S5, S6, S7, S8, S9. Okay, I will write S5, S4, S5, S6, S7, S8, S9. See here, S0 we have to find. So I will write 1 at an angle of, consider 0, right, because k equal to 0. Here it is nothing but sk is equal to 1 at an angle of theta k, right. So first we have to find theta k. So k is 0, pi into 0 is 0. So here this term is 0. Now pi divided by 10 plus pi by 2. This term is 0 when theta is 0. This term is 0 plus pi by 10 because n equal to 5 plus pi by 2. So LCM is 10. So 10 pi plus, so 5 here, 5 pi. So 6 pi by 10. 6 pi divided by 10. So just substitute here, 6 pi divided by 10. Now use the calci. So 1, shift the A is written on the this one. So the angle will come, take into the bracket 6, shift pi divided by 10. So it will give the answer like, just check it. What is the answer? Minus 309 plus J of 0.95. Similarly, 1 at an angle of, when k equal to 1, pi into 1 divided by 10. Here, when theta value, when k equal to 0. So one more I will show you, k equal to 1. Theta 1 is equal to, so 1 into pi divided by 5 because n equal to 5 plus pi by 10 plus pi by 2. Sorry. So LCM is 10. So here 2 pi plus pi plus 5 pi. So 8 pi by 10, 8 pi by 10 or else 4 pi by 5. Both are same. So 4 pi by 5. So calculate the values. Yeah. So it is nothing but minus 0.809 plus j of 0.588. Calculate the next value. K equal to 2 now. Right? K equal to 2. K equal to 2 theta 2. So 2 pi, right? So 2 pi because K equal to 2 divided by 5 plus pi by 6, no, pi by 10 plus pi by 2. So here again LCM is 10. So 10 pi plus pi plus 5 pi. Alright. So calculate. So 16. Yes. Calculate. So 10, 11, 11 plus 5, 16 pi divided by 10. That is nothing but, yeah, 16 pi divided by 8. So just calculate, substitute the values. So I will write directly the answer. Here 1 at an angle of pi, that is nothing but minus 1. The next one is 1 at an angle of 12 pi divided by 10 is equal to minus 0.809 minus 0.588. S of 4, 1 at an angle of 14 pi divided by 10 is equal to minus 0.309 minus j of 0.951. Right, calculate the values. Similarly this one. Right, so yeah, similarly this one 0.309 minus j of 0.95. Opposite to this one. Next, opposite to this one 0.809 minus j of 0.588. Next, opposite to this one. Here minus 1 is there, here it is plus. So opposite value 0.809 plus 0.588. Opposite value 0.309 plus j of 0.951. See here, if you plot the poles diagram, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So S0, S1, S2, S3, S4, S5, S6, S7, S8, S9. Alright, so if you want, you can remove it, the reference line. Alright, so see here, S0 opposite is S5. See here, S0 and S5. Only the opposite direction. S1 and S6. S2, S7. S3, S8. S4, S9. See, one part you can calculate. The next one is just, it is the opposite sign. Just you have to make the entire answer with the -1. Alright. So after that, I will write the transfer function for fifth order. Once you have calculated, the transfer function of fifth order. The next one, once I have calculated poles, I will write the transfer function of fifth order. That is nothing but this one. It is, we have to consider only the left side. The left side poles I have to consider. That is nothing but, I will write S of 0, S of 1, S of 2, S of 3, S of 3, and S of 4. So order is 5. So 1, 2, 3, 4, 5. Right. Substitute the values. H5 of S is equal to 1 divided by S minus S0. What is S0? This value. 1 minus plus 0.309 minus J of 0.95. S1 is this one. S plus 0.809 minus 0.588, and then this one minus plus S plus 1. The next one here, S plus 0.809 plus 0.588. This one, S plus 0.309 plus J of 0.95. Right, once you have calculated this one, simplify this one. Just to make the multiplication. So this one is, and this one is common. Alright, so real term square minus the imaginary square, and make it simplification, because minus j square we will get plus 1, right, and make the further simplification. I will write, after the simplification we will get the equation like this: S plus 1 S square plus 0.618 S plus 1 S square plus 1.618 S plus 1. This is nothing but H5 of S. Use the calci, simple multiplication. In the calci also we'll get the terms, right? Just to make the real term square plus imaginary square. imaginary square, once you have done, I square is nothing but -1. Alright. So there is a no imaginary part you will get in the final equation, remember. Right. So only the pure real terms will get it in the function. Once you are done, if you want, you can make the further simplification. H5 of S is equal to 1 divided by, make the further simplification, S of 5 plus 3.23 S raised to 4, 5.23 S cube plus 5.23 S square plus 3.23 S plus 1. Make the multiplication here. So this one and this one multiply, you will get 9 terms. Make the further simplifications. After that, multiply entire thing with the S plus 1 and make the further simplification. You will get this equation. This equation. After that, once you are done, once you have calculated the transfer function, we have to calculate the cutoff frequency. Alright. So we have to calculate the cutoff frequency. This is the last step. Right. So we have to calculate the cutoff frequency, that is nothing but omega c value. What is that omega c? So omega c is nothing but, we have the equation omega p divided by 10 to the power minus kp divided by 10 minus 1 divided by raised to 1 by 2n. We know the omega p. What is the omega p value? 4. Omega p is 4 divided by 10 to the power. What is the kp value? Kp value, it is nothing but -1. So minus minus plus. So 10 to the power 1 by 10 minus 1 divided minus 1 raised to 1 by n. 1 by n. What is 1 by n? What is the n value? 5. So here it is raised to 1 by 10. Make the further simplification and get the answer. So it is nothing but 4.5787 radian per second. So in the last, if I want to write the transfer function last step, so whatever the value is there, h5 of s, h5 of s is nothing but this one, or the final equation. So in that equation, just you have to replace s by s divided by omega c. So wherever the s is there, s is replaced with s by omega c. You will get the final answer. Right. So that is nothing but s divided by 4.5787. Right. So the last step, wherever the s is there, just you have to replace s by s divided by 4.5787. So we have the equation. So that is nothing but HA of s, the last equation. So 1 divided by s raised to 5. What is s now? S divided by 4.57 raised to 5 plus 3.23 S divided by 4.57 S square. No, S raised to 4. Remember, here it is 4. Plus 5.23 S divided by 4.57 S3. 5.23 S divided by 4.57 S square plus 3.23 into S divided by 4.57 plus 1. Make the simplification. Alright. So 4.57 raised to 5, because it is a common the value, just you have to multiply, right? So multiply with the highest denominator, that is nothing but 4.57 raised to 5. If I multiply, I will write the right. So multiply and divide, right? So just if you multiply it, so multiply and divide, right? Multiply and divide. So 4.57 raised to 5. So here, or else multiply denominator and numerator. So if I want to reduce the confusion, multiply, right? Multiply 4.57 raised to 5 to the numerator and denominator. If I multiply this one to the numerator and denominator, right? So if I multiply to the numerator and denominator, so we will get HA of S. So 4.57 square, I will write it is nothing but 2012.4 divided by, if I multiply here this one and that value will get cancelled, we will get S raised to 5. Here only we have to multiply with 4.57, so that is nothing but 14.82 S raised to 4 plus 109.8 S cube plus 502 S square plus 1422 S plus 2012.4. Yeah, this is the final the transfer function for the low pass analog filter, right? So this is the final answer. Just check it. Try to get this equation at least. Try to get this equation. After that, if you just this one is fine. Alright. So if the time permits, just go for the calculation. It is also very easy if you use the calci. See here once again, I will brief the steps. For the filter design, just you have to see that which filter design is asked. Either it is for low pass filter, high pass filter, band pass filter and band stop filters, right? So given numerical, it is for so low pass filter is there. So for the low pass filters, right? So the first step is we have to find the order of the filter, right? So filter order we have to find. Filter order we have to find. What is the equation for filter order? So we know the equation. N is equal to, remember, log of 10 to the power minus Kp by 10 minus 1 divided by minus Ks divided by 10 minus 1 divided by 2 log omega P by omega S. So by this equation, for this one, just we have to put in the calci, complex and radian mode. So here no, so following this one, calci should be in the complex plus radian mode, right? Then only you'll get the correct answers. Otherwise, instead of order 5, you may get around 20, 30, 40. It is wrong. Keep it in mind. Right. So once you have calculated n, the next step is step 1, step 2. What is the next step? The next step is nothing but we have to find the poles. So Sk is equal to 1 at an angle of theta k. What is the theta k? Theta k is nothing but pi k by n plus pi by 2n plus pi by 2. Remember this one. And here k is varying from 0 to 2n minus 1. If order is 4, 4 into 2, 8, 8 minus 1, 7. So means 0 to 7. We have to compute the values. Alright, the third step. So if the order of the system, if I want to write, so depending on the order, so just you have to write S minus S1, S minus S0, S minus S1, S minus S2, S minus S4, and so on, up to number of order of the filter. If it is 4, so S0 to S3. Only the 4 values, 1, 2, 3, 4. If it is order is 3, 1, 2, 3, 3 values will be there. So like that. Right. So once we compute this one, right. So the next step, simplify this one, right. After that, we have to find the cutoff frequency. What is the cutoff frequency equation we have? So it is nothing but omega p divided by 10 to the power kp by 10 minus 1 raised to 1 by 2n. So calculate the omega c value. Once you have calculated omega c value, so just you have to, for the low pass filter, just you have to replace S is nothing but S divided by omega c, right, in the final equation. So H of S is nothing but H of, I will write this one is H of S, HA of S. Here S is replaced with S divided by omega c. So you will get the final transfer function for the given filter. These are the steps, remember, right? So in the next class, we'll discuss about the one more filter, Chebyshev filters. After that, one more class we'll discuss about the window techniques and we'll finish it. Right? If anyone having any doubts, you can contact through WhatsApp. So I'll be available and I will clear your doubts. And these numericals already solved in the regular lab session also, right? So one numerical on this one numerical on the Chebyshev filters, and you have written the program for these filters also.